Now it's time to learn how to name substituted alkanes. And we're going to start with alkyl halides. Now, I know that we've talked a little bit about how to name alkyl halides, but we're going to kind of do this in a formal manner. The formula for alkyl halides is CnH2n plus 1 X, where X can be a fluorine, a chlorine, a bromine, or an iodine. Um, And so notice that a halogen essentially takes the place of a hydrogen. And so instead of 2n plus 2, you have 2n plus 1 hydrogens. And then you have the halogen. And the way that we name alkyl halides is the same as the way that we name alkanes. And the only really big difference is that the name of the halide is used as a substituent. So for example, if I have fluorine as a substituent, it's called a fluoro group. If I have chlorine, it's called a chloro group. If I have bromine, it's called a bromo group. And if I have iodine, it's called an iodo group. Now, there are also common names that are oftentimes used for the simple alkyl halides. And I'll show you a couple of examples of common names as well. So let's start off with this particular compound, CH3F. And in the IUPAC nomenclature, we would name this fluoromethane. So fluoro is the substituent coming off of a methane chain. Now, this also has a common name, which is called methyl fluoride. Methyl fluoride. Likewise, here I have a 3-carbon chain with a bromine on the end, and so in terms of the IUPAC nomenclature, I would number the carbon chain with the bromine getting the lowest number possible. So I would number the carbon attached to the bromine carbon number 1, and therefore this would be 1-bromopropane. However, this is a relatively simple alkyl halide, so it has a common name as well, which would be propyl bromide. Propyl bromide. Here I have an alkene. This is ethene with a bromine attached to it, and therefore this would be called bromoethene. But this also has a common name, and we talked about the sp2 hybridized carbons on an alkene being called vinyl carbons, and so and that is a vinyl group, so this is called vinyl bromide. And of course, you know, when we get into a little bit more complicated alkyl halides, we typically don't have common names associated with them. So this would simply, you would count the number of carbon chain, which is 5-carbon chain. You would number the carbon with the chlorine attached to it, carbon number 2, so this would be 2-chloropentane. And here I have another alkene with an iodine coming off of it. Again, notice the alkene takes precedence in terms of numbering. So this is a 4-carbon chain. I would number it starting at the at the left-hand side with the alkene carbon number 1, and then the carbon with the iodine on it would be carbon number 3. So this would be 3-iodo, 1-butene. I can also do cycloalkyl halides. So in this particular example, again, bromine is a substituent. It doesn't take any precedence between alkyl groups and halogens, so you simply name it and number it according to the lowest possible number possible around the ring. So if I started with the carbon with the bromine attached, the locants would be 1, 3, 3, and if I started on the carbon with the 2 methyl groups, the locants would be 1, 1, 3, and therefore I'm going to start in that direction. So I get 3-bromo 1,1 dimethyl cyclopentane. Now, in terms of classification, alkyl halides can be classified as methyl halides, primary halides, secondary, tertiary, or vinyl halides. So chloromethane or methyl chloride is a methyl halide, right? Because there's only a methyl group attached to the halogen. And of course, I could draw a number of different alkyl halides. This particular alkyl halide, the longest continuous carbon chain is a 4-carbon chain, so this would be 1-bromo-2,3-dimethyl butane. But notice the carbon in which the halogen is attached is a primary carbon because it only has one carbon attached to it. So this is called a primary halide. Here I have a structure where I have some alkane group or alkane with an iodo substituent coming off of it. And if you look at the carbon attached to the iodine, it has 2 carbons attached to it, and therefore this is referred to as a secondary halide. And here I'll show an example of a tertiary halide. So you notice that the carbon where the fluorine is attached has 3 carbons attached to it, and therefore it's called a tertiary halide. And vinyl halides, an example of a vinyl halide is simply where a halogen is attached to one of the vinyl carbons. So this is called a vinyl halide. And that's how you classify halides. And as a matter of fact, that's how you classify alcohols as well. And we're going to get into naming alcohols. And so, keep that in mind that this classification expands into alcohols as well. So let's take a look at how we name alcohols. And we haven't really spent any time talking about the names of alcohols, so I'm going to spend a little bit more time in just terms of the rules of alcohols, and that is that essentially you replace the E of the parent alkane with OL. So propane becomes propanol, butane, you drop the E, you add an OL, becomes butanol, and so on and so forth. Now the big difference here is that the alcohol functional group takes the lowest possible number relative to other substituents of alkane derivatives, right? So it takes precedence, we say, over the other substituents. So here I have a CH3OH. So the OH, if I look at the base name of the carbon chain, would be a methane. So I drop the E, I add an OL, and I get methanol. Here I have a 4-carbon chain, so it would be butane, and you drop the E and you add an OL, and the alcohol is on the 2nd carbon, so I call this 2-butanol. Here I have an alcohol that has the OH on the 2nd carbon of the longest continuous carbon chain of a 3-carbon chain. So 3 carbons would be propane. I drop the E, I add an OL, it becomes propanol. And if I number it, 1, 2, 3, then I have another substituent on the ring, a methyl group, on the 2nd carbon. So notice I have an OH group on the 2nd carbon, I have a methyl group on the 2nd carbon, and therefore this would be 2-methyl 2-propanol. And here I have 2 substituents on this 4-carbon chain. I have a halogen and I have an OH. And notice I could number this starting from the left to the right, 1, 2, 3, 4, and the chlorine would get a number 2 and the OH would get a number 3. But remember, OH takes precedent over all other substituents based on what we know so far, and therefore I have to number this the opposite direction, 1, 2, 3, to give the OH group the lowest location, the lowest locant possible, and therefore this becomes 3-chloro-2-butanol. And here is an example of a a cyclic derivative where, again, I'm going to number the carbon with the OH group, carbon number 1, because that's the lowest locant I can give it, and therefore the carbon with the fluorine on it gets labeled number 3. If I go kind of up, 1, 2, 3, and therefore this becomes 3-fluorocyclopentanol. Now, there are some common names of alcohols that are in wide use and are certainly worth remembering. So an example of that is this particular structure right here. Now remember, a carbon coming off of a vinyl carbon is called an allele carbon. So this simple allele alcohol is called allele alcohol. And we have structure like this, where you have a benzene ring, and attached to the benzene ring is a carbon with an OH. Now that carbon is called a benzyl carbon. So just like an allele carbon, we have allele alcohol. When you have an OH group coming off of a benzyl carbon, it becomes benzyl alcohol. I can also have an OH group coming off of the benzene ring itself. Now, interestingly enough, when benzene is a substituent, it's not called a benzyl substituent, right? Because the example I just showed you is called a benzyl substituent. Instead, benzene as a substituent itself is called a phenyl group, P-H-E-N-Y-L, a phenyl group. And when there is an alcohol, there's a very common name that's used exclusively, and it's called phenol, phenol. So we drop the YL and we add an OL, phenol. Now there are also very common diols, and here is an example of a very common diol, and the name of this is ethylene glycol, ethylene glycol. And so it's very, it's certainly worth remembering this one because we use this as solvents. You're going to see this from time to time being used as a high boiling point solvent. And an example of a triol is this very simple triol, which is called glycerol. So glycerol is a byproduct of the what's called a saponification reaction of fat. So when manufacturers make soap, they make one of the byproducts of soap production is glycerol. And so for many years, glycerol has been used in makeup, so as a foundation in makeup. So a lot of creams have glycerol in it. And sometimes you'll see this named glycerin. And of course, through the years, we've also been able to find out ways to take glycerol because we used to make so much of it in the beauty industry that we were able to nitrate glycerol, and you get nitroglycerin. So that's where nitroglycerin comes from. Okay, so now let's take a look at how you name amines. And amines are named a little bit different, but like alcohols are organic derivatives of water, amines are organic derivatives of ammonia. So if you remember from general chemistry, ammonia is NH3, right? So that's ammonia. And so whenever there is an alkyl group as a substituent, in place of one of the hydrogens, then it becomes an amine. So I can have one alkyl group replacing one of the hydrogens, and I get what's called a primary amine because the nitrogen has a carbon attached to it. And so the classification for amines is quite a bit different than the classification for alkyl halides and alcohols. Remember, when we classify alkyl halides and alcohols, we're looking at the carbon attached to those substituents and how many carbons are connected to it. When we're classifying amines, we're looking at how many carbons are attached to the nitrogen itself. So that's a little bit different, and you have to kind of keep that straight in your head. If I have two alkyl groups coming off of the nitrogen replacing two hydrogens, this becomes a secondary amine. And of course I can replace that last hydrogen with an alkyl group and this becomes a tertiary amine. Now, I can go one step further and replace, and I have that pair of electrons that I can use to form another bond, and I can put four alkyl groups around a nitrogen. When I do that, the nitrogen takes on a positive charge, so I get a salt. And so instead of, if we think about ammonia being protonated, it becomes ammonium. Well, these are ammonium salts. They are organic ammonium salts. Now, with primary amines, you can also name the alkyl group followed by amine. So this is how you name primary amines. You simply name the alkyl group coming off of the nitrogen, and then you follow that by amine. For higher amines, higher classified amines, you simply list the alkyl groups alphabetically. So you list all the alkyl groups, and then you follow that by amine. So let's start with a very simple one. CH3NH2 is called methylamine. Methylamine. Very different than than naming alkyl halides and alcohols. So kind of keep that straight in your head. Sometimes you can even shorten this. So instead of saying methylamine, you can say methamine. Methamine. So dropping the YL and combining it into one word. Methamine. Here I have, notice there's a benzene ring with the CH2 coming off. That CH2 is a benzyl carbon, so this is called benzylamine or benzamine. And then I have here a secondary amine, right, because it has two alkyl groups coming off of the nitrogen. One of the alkyl groups is a propyl group. One of the alkyl groups is an ethyl group. And therefore, I simply list them alphabetically. Ethyl comes before propyl, and this becomes ethyl propyl amine. And that's kind of the basis for naming amines, right? You simply list them in terms of the alphabetical listing of the alkyl groups. Now, there is another way to name primary amines, and that is by naming them as substituted alkanes with amino being used to designate the NH2 group. So an amino group is a substituent coming off of a carbon chain. This is typically used for primary amines. It can be used for some secondary and tertiary amines where if you have a simple secondary tertiary amine where one of the alkyl groups is like a methyl or an ethyl group, the naming is a little bit different, and we won't go into great detail about that, but every once in a while you'll see you simply name that amino group with a methyl group coming off, and you designate the letter N, N-methylamino. And you'll see that from time to time. But for the most part, here I have a primary amine. I also have an alcohol. So the easiest way to name this is as an ethanol with an amino group attached to it. In terms of numbering, so I have these two carbons, the alcohol takes precedence, so that carbon gets number 1, the carbon with the amine gets carbon number 2, so this becomes 2-amino ethanol. Notice I don't have to really name one ethanol because it's assumed that the numbering scheme came from the OH numbering that carbon number 1. So here I have, an example of a cyclic alcohol and amine. Notice I'm throwing in a little bit of stereochemistry here. So if I look at how to number this, obviously the carbon with the OH would get carbon number 1. The carbon with the NH2 would get carbon number 3. Now, if you remember how, you always have to remember how to assign priorities and give absolute configurations. So carbon number 1, the OH would be number 1, the carbon on the right would be number 2, and the carbon on the left would be number 3. The hydrogen's coming out at me. I'm rotating in a counterclockwise, but the hydrogen's coming out, and so this is R. As for the carbon with the nitrogen gets the highest priority, followed by the carbon at the bottom, followed by the carbon to the left, and it's rotating in a clockwise manner. The hydrogen's going back, and so this is also R. And therefore, this would be named 1R, 3R, 3-amino cyclohexanol. Here's an example where I have 2 primary amino groups, but I also have an alcohol, and therefore, again, this is going to get the designation of an alcohol with the NH2 groups as substituents. Again, I have to number this starting on the right-hand side so that the OH gets carbon number 2. Then one of the NH2 groups is on carbon number 3, and the other NH2 group is on carbon number 5, and therefore this is 3,5-diamino 2-pentanol. And here's another example of a ring. Now, in this particular example, I have a bromine and I have an NH2. Amines take precedence over alkyl halides. They also take precedence over alkyl groups as well. So I would number this starting with the carbon on the that has the nitrogen attached to it, and it would be 3-bromo-cyclopentylamine or 3-bromo-cyclopentamine. So just another little variation. Either one of them is correct, right? So you could use either one, and you would be correct in that, in the way that you would name that. Okay. All right. Now, cyclic amines have common names that are almost always used, and this is probably a big sticking point for a lot of students, because you see all these nitrogen containing rings and they have very strange names, and you're going to see that they have very strange names, but I'd like you to get to know these names because they're going to pop up from time to time. So the first one, the smallest cyclic amine, is a 3-membered ring with nitrogen on it. And the way that you name this is called aziridine. Aziridine. Now, you can also name this as what's called an aza-cycloalkane. So this would be aza-cyclopropane. Aza-cyclopropane. The aza stands for the nitrogen. When you have a 4-membered ring with a nitrogen in the ring, this is called azetidine. Azetidine. Again, you can name this as an aza-cyclobutane. So aza-cyclobutane is an IUPAC name, but the common name is azetidine, and we'll be using that. And I'll be using that from time to time. So if you hear me say aziridine, it's 3-membered cyclic amine. If you hear me use azetidine, it's a 4-membered cyclic amine. Okay. And then of course we have a 5-membered ring, and it also has a common name called pyrrolidine. Pyrrolidine, and it has the IUPAC name of azacyclopentane. And then lastly, I'll show you is a 6-membered ring. And 6-membered rings obviously can be azacyclohexane, but the common name for this is piperidine. Piperidine. Piperidine is the spice of black pepper. Now, I can also have a nitrogen in a benzene ring. And when I have a nitrogen in a benzene ring, this is called pyridine. Pyridine is a very common solvent. You're going to see this used a lot. It's a kind of a cool solvent because it's also a base. So whenever we run reactions in which one of the byproducts is an acid, oftentimes we'll use pyridine as the solvent because it will react with the acid, and you get a salt from that. Okay, so here's an example where I have a derivative of piperidine. And whenever you have a derivative, you always start numbering at the nitrogen. So 1, 2, 3. So the methyl group's on the third carbon, and this becomes 3-methylpiperidine. 3-methylpiperidine. So that is how we name amines. And just to talk briefly about ammonium salts, the ammonium ions are named in a similar manner as amines, except that you use ammonium instead of amine, and then of course there's an anion that's associated with it that you also have to name. So for example, here I have CH3CH24 N plus bromide. So there's 4 ethyl groups attached to the nitrogen, and therefore this would be tetraethyl ammonium bromide. So tetraethyl ammonium bromide. That's how you would name that. And I can have different types of alkyl groups coming off of the nitrogen. Here I have 2 ethyl groups and 2 methyl groups. Again, I alphabetize them. This becomes diethyl dimethyl ammonium chloride. Diethyl dimethyl ammonium chloride. And I don't have to have, notice I don't have to have all alkyl groups coming off of the nitrogen. So I might just have 1 alkyl group coming off of the nitrogen, and I have 3 hydrogens. So this is still a salt, an ammonium salt. There's 1 propyl group coming off of the nitrogen, so this becomes propyl ammonium fluoride. Propyl ammonium fluoride. That's how we name those ammonium salts. Now the last substituted alkane that I want to talk about are ethers. And there are 2 common ways to name ethers. So the IUPAC nomenclature is to consider the longer R group coming off of the oxygen as the parent chain, and then the shorter R group plus the oxygen is called an alkoxy substituent. This is the way that IUPAC wants us to name ethers, but there's also a very common way, and that's simply to name the 2 alkyl groups coming off of the oxygen and then list them alphabetically, followed by the word ether. So kind of similar to amines. So as an example here, we have an ether with 2 methyl groups coming off of it. In terms of IUPAC nomenclature, methane would be the longest continuous carbon chain, and a methoxy group is coming off of it, so this is called methoxymethane. We almost never say methoxymethane. Instead, it's simply dimethyl ether, dimethyl ether. Likewise, here's a simple ether with 2 ethyl groups coming off of it. In terms of IUPAC nomenclature, the longest continuous carbon chain is still 2 carbons, so this is ethane, and there's an ethoxy group coming off of it, so this is ethoxyethane. But again, we never call this ethoxyethane. This is instead diethyl ether, that common solvent that we often use in lab, diethyl ether. And sometimes we even abbreviate it further, simply ethyl ether. So here's an example where I have an ethyl group and I have a propyl group. So the longest continuous carbon chain would be propane, and then the ethyl with an oxygen is ethoxy. So I have 1 ethoxy propane, right? Because I number the carbon with the oxygen attached to it, number 1. So this is 1 ethoxy propane. But again, common name, I could simply name the 2 alkyl groups, an ethyl group and a propyl group, and therefore this becomes ethyl propyl ether. Ethyl propyl ether. Now, excuse me. In terms of cyclic ethers, they're named several ways. They have common names. They can be named as oxa rings, just like cyclic amines can be named as aza rings. These can be named as oxa rings, or they can be named as oxides. So here is the simplest cyclic ether. Its common name is ethylene oxide. Ethylene oxide. Well, it's an oxide. It also has a more common name called oxyrane, but it can also be named as an oxa ring. So this is oxacyclopropane. Any one of these 3 names is a correct way of naming ethylene oxide. So typically I call this ethylene oxide. Now I can go one step further and I have now here's a 5-membered ring. So in terms of the oxa ring, it'd be oxacyclopentane, right? That's an easy way of thinking about naming it, maybe. But if you think about, I have essentially 4 methylene groups plus this oxygen. So oftentimes you'll hear this referred to as tetramethylene oxide. But we also have a common name associated with it. It's called tetrahydrofuran. Tetrahydrofuran, which we often abbreviate THF. This is a common solvent that's used. THF is an ether, and it's used in a manner kind of similar to diethyl ether. Now, where does the tetrahydrofuran come from? Well, if I look at this particular ring, this ring with the 2 double bonds, it has a common name called furan, and if I add 4 hydrogens to furan, I get tetrahydrofuran, which is that THF. So that's where that naming system comes from. Okay. So lastly, I can have more than one heteroatom on the ring, or in the ring. So here I have 2 oxygens in the ring. This is a very common ether called 1,4-dioxane. But in terms of kind of the IUPAC way of naming this, it would simply be 1,4-dioxacyclohexane. And I can have a structure like this where I have 2 oxygens in a cyclopentane ring. This also has a common name called 1,3-dioxolane, but in terms of IUPAC, it would be 1,3-dioxacyclopentane. Now, just to give you a few more, common names that you might see from time to time. This is a very common structure, and we might name this methyl phenyl ether, but it has a very common name. So when you have a CH3O, a methoxy group coming off of a benzene ring, it's called anisole. I can also have different heteroatoms in a ring. So I can have an oxygen and a nitrogen in a ring. So here I have a 6-membered ring, oxygen and nitrogen. And how do you name something like this? Well, there's a common name, and it's called morpholine. And of course, we can put a substituent on morpholine. And how do you think you would name this substituent? Where do we start the numbering system? On the oxygen or on the nitrogen? Well, just like alcohols take precedence over amines and all other substituents, the oxygen on a ring takes precedence over nitrogen. And so we number this starting at oxygen 1. So this would be 3-methylmorpholine. So that gives you an idea of how to name various substituted alkanes, and you see sometimes they can be relatively easy, sometimes a lot of the common names can get you a little confused. Practice on using some of these common names. They might pop up from time to time, and I want you to be aware of it, but certainly know how to name using an IUPAC nomenclature of relatively simple alkyl halides, alcohols, amines, and ethers. All right?